For Dyson engineers, breakthroughs in technology always come by questioning, testing, often trying what seems like the wrong solution. It leads to radical invention. We're risk-taking all the time. If you always do what you know is going to work, then okay, you'll have less failure, but you'll never make a quantum leap. That's why we're constantly innovating.
The problem with conventional hairdryers is they have conventional motors. They can be large, bulky and slow. This tiny fan we see in front of us, this impeller, is only 27 millimetres wide and spins up to 110,000 RPM. Because of the high speed of this motor, it allows us also to generate high airflow pressures. The Dyson V9 draws in 0.8 metres cubed of airflow per minute, but that gets amplified as the air passes through the air multiplier technology to 2.4 metres cubed per minute.
To dry hair, you need a combination of velocity and temperature. So if you just had heat, for example, it would evaporate the water from this hair, but it would take a very long time. Velocity can also help to start to strip off water from the surface.
We were able to focus that pressure through this aperture here, and we did a huge study on this aperture and converting that pressure from the V9 motor.
The unique combination of our Dyson V9 digital motor here and our air multiplier technology gives us high pressure, high velocity air to help dry fast.
From my huge experience in motor and airflow technology, the next thing was to just do a massive understanding, a 5-year understanding into the science of hair.
I think we all associate healthy hair with shiny hair. So protecting hair from extreme heat will help to preserve the shine.
When you use any products that go above 150 degrees Celsius, structural changes start to take place in the hair.
Hair is made up of several layers. This cortex is made up of keratin. And if hair is heated excessively, it can punch holes in the strands. That will cause light to scatter and the hair will look dull.
Dyson have solved this problem by incorporating an intelligent heat control system which measures the temperature of the airflow. It feeds information back to a microprocessor 20 times per second, and if it starts to get too hot, then the system will cool down the heating element, which means that the airflow will never exceed a certain extreme temperature at the outlet. So when you put the temperature into the highest heat setting, it will always stay at a constant level of temperature rather than going too high or too low during styling.
For decades, conventional straighteners have relied on solid plates. But solid plates don't gather the hair, so there is limited control and tension is applied unevenly. This means they rely on excessive heat, which increases hair damage.
So we tried to create a plate that would be more adaptive to the hair. So we created a flexible plate, something that actually applies even pressure and temperature.
The temperature of our flexing plates is regulated 100 times per second. using intelligent heat control technology.
From day one, we're testing on hair tresses like these in the lab because we need to understand the interaction a product has with the hair. So we use our hair science laboratories and hair experts. But you can't just understand the interaction from a tress of hair. You need to put it in a user's hands.
Hair on a real person may be more damaged, they may have different behaviours, different routines.
That's the sort of feedback you get from a real human, and then you really understand sort of like the little minute details in the product.
The machine has 3 heat settings and is powered by 4 lithium-ion batteries. All of this inside such a small package is so crammed full of technology. We even have to cut out micro parts of the wall section to cram it all in. The product's used at the top of people's heads, so you've got to make sure that it's going to survive a fall of that height. So we had to do a lot of drop testing to ensure that if you drop this product, A, it will still work, and B, it will be safe.
To straighten hair effectively, you need 3 things: heat, tension, and control. We discovered that the less control and less even tension you have, the more heat you require. And the more heat you use, the more you damage your hair. So we created flexing plates, made of 15 individual facets of a manganese copper alloy that are adaptive. By shaping around the hair to gather it, they provide an effective combination of control and tension, which means you can produce the same style with reduced reliance on heat.
When we launched the Dyson Air app, it revolutionised styling. Since then, we have refined our attachment technology to improve usability, versatility and performance. I think one of our biggest achievements with these attachments is how effective and intuitive they are to use. This is the result of the optimised geometry and refined engineering inside them. The air up barrels were a really interesting design challenge. We focused on finding a way to achieve both directions of curls on one barrel to give you optimal control and styling in an easy to use way. The brush attachment has been re-engineered with enhanced coander airflow. On the new design we've got these vanes which turn and guide the flow. This gives you precision coander airflow for controlled style and alignment. The coander smoothing dryer has 2 modes. Firstly, it has the drying mode. You can then switch into smoothing mode. This uses the coander effect to sort the hair and reduce the flyaways, giving you a nice smooth finish. All of these attachments have been designed to give you optimal control and styling in an intuitive and easy to use way, without the need for extreme heat.
When you're curling hair, you're using either heat or moisture to change the bonds within the hair structure. So you're breaking those bonds and you're setting new bonds to create a new shape. When we use hot styling tools like tongs, we're relying on heat to change the bonds within the hair structure and then reset them in a new style. The problem with using this method is that extreme heat can damage hair, and hair can't heal itself, so that damage can be permanent. Alternatively, when hair is wet, the water breaks the hydrogen bonds within the hair strands. Then when the hair dries, the hair is reset into that new shape. Kind of like when you go to sleep with your hair wet and you wake up with your hair in a funny shape. What we wanted to do was to create a tool that would create curls from wet to dry, similar to how a stylist would, but make it easy to do. Using air helps to get volume into the curl and avoid extreme temperatures.